Yes, we're still continuing with our summary of functions, and now in the third here, we're looking at 3 Roman numeral 1. A mapping diagram is an arrow diagram with a set of values of x and that of f of x. So we're having two values that we consider here: the set of values of x and the set of value of f of x. Then these sets are grouped into two. One is the domain, the other is the range. So in Roman numeral 2 here, we're saying a set of values of x is the one we call the domain. And then a set of values of f of x that we get from x is the one we call the range. So we now know the domain and the range as the content of our mapping diagram, which is an arrow diagram. And then number 4 here, we now talk about the inverse. Remember, we are trying to summarize functions, and then we shall look at the examples and questions after. The inverse of a function f of x is denoted by f inverse, f power negative 1 of x. So that is read as inverse of f of x. This function is the one, remember we get the range from the domain. Now this function maps the range back onto the domain. In other words, it maps the set of f of x values back to the set of x values. And still in our summary, we now look at a function that is undefined. A function that is undefined is one whose denominator, first it has to be a rational function. Rational meaning it has a numerator and a denominator. Now that function whose denominator is equal to 0 is said to be undefined, or you can say meaningless. And lastly but not least, we look at a composite function. A composite function, f g of x, is a combination of two functions, f of x and g of x, or any other function the way it may be defined. And a composite function, f squared of x, is the same as having f x. So you can even have f cubed of x. That means f x, like that. It can even be power 10 if needed. I mean, we can have something like this as well. If it is f power 4 of x, then that means it is f of x. As simple as that. These are said to be composite functions. We call these composite functions. Now we move on into an example. We need to see an example at least concerning the range and the domain. Range and the domain. So in this question, as you can see right here in this particular example, we are asked to determine the corresponding range to the domain 0, 1, 2, 3 for a mapping of f of x into 3x plus 3. That means every f of x, to acquire it, you have to multiply the x by 3 and then add on 1. So this is very simple. So we have the domain right here for part 1. We have the domain and we have the range. The domain is a set of x values which is to be mapped into a set of f of x which is defined as 3x plus 1. So we have our x values as 0, 1, 2, 3, and now 3 times 0 is 0 plus 1, you get 1. And then 3x means 3 times 1, which is 3 plus 1 to give us 4. In that order, 3 times 2, because it is 3x, that is 6 plus 1, 7. And then 3 times 3 is 9 plus 1, that gives us 10. So our range is a set of values which you can call R, and we have 1, 4, 7 as well as 10. This is what we have as our range. Now, representing this mapping in one above on an arrow diagram, that would be the simplest thing we can ever be asked under functions. So we have now our domain, which is 0, 1, 2, 3, and we have our range, which is 1, 4, 7, and 10. In this case, we don't have any repeated values, so we have this, and we have the range as that. So, remember, we said this is strictly an arrow diagram. A mapping is an arrow diagram. So we're going to have 1 has been mapped into, 0 has been mapped into 1, and then 1 has been mapped into 4, and 2 has been mapped onto 7, and then 3 has been mapped onto 10. This is a one-to-one because every single value of the domain is being mapped to a single value or in the range. So we have the x being mapped into 3x plus 1. That would be our solution for this number, and I hope you have enjoyed it. This is Video Learning Uganda as we continue learning while at home. Remember, we're still continuing with our series of functions and mappings.